Hello everyone, today I am going to do a video on find inflection points in Khan Academy. So let's start. Let g of x equals to x fourth plus 4x cubed minus 18x squared. For what x values does the graph of g have a point of inflection? So the point of inflection is in which the second derivative of the function changes sign, switches sign. So first let's find g prime. G prime of x equals to 4x cubed plus 12x squared by using the power rule minus 36x. So let's find the second derivative of g prime of x. This is equal to the derivative of this. So let's use the power rule again. So 12x squared plus 24x minus 36. So this is our second derivative. So let's see. Let's see when this is equal to 0. So we can factor out an 12 from it. So this becomes x squared plus 12 x squared plus 12x equals to minus 36. 12 times 3 is 36 minus 3 minus 3. This is equal to 0. So let's factor out. So let's say plus equals to 12 and times equals to 3. Times equals to 3. So this becomes, when does it become like that? So 3 times 1 is the only option. So this is plus and this times. So this becomes let's try to solve it. So when we factor out and 12 from this becomes x squared plus 12x. This was x minus 12 times 3 is 36. This is equal to 0. So x squared plus 12x equals to 3. X squared plus 12x equals to 3. X squared plus 12x equals to 3. We can factor out an x times x plus 12 equals to 3. So minus 3 equals to 0. Let's erase all of this and let's see. For what x values does the graph of g have a point of inflection? So when this is equal to 0, so we can only factor out in 12. So 12 times x squared plus 20 plus 12 plus 2x. 12 times is 2. I mistakenly done wrong. So plus 2x minus 3. This is equal to 0. So we can divide from with the 0. So this becomes 0 and plus equals to 2 and times equals to 3. So this can be only done by 3 and 1, and we have to do minus 3, so we can do like this. So this becomes x squared plus minus x plus 3x plus 3x minus 3 equals to 0. Let's factor out an x times x minus 1 plus 3 times x minus 1. So this becomes x plus 1, x plus 3, x minus 1. X plus 3, x minus 1. X plus 3 times x minus 1 equals to 0. So this is only 0 when this is equal to 0 or this is equal to 0. So this is equal to 0 only when x is equal to negative 3 or in this case 1. So these are our inflection points. So let's see now. Let's make a number line. So let's say this is number 9 and this is 0, this is 1 and this is negative 3. So we have to choose between these. So let's say between these points, let's pick a value, let's say 0.5. So this becomes 12 times 0.5 squared. 0.5 squared is equal to 0.25 times 12 equals to 3 plus 24 times 0.5, or this is just 12. This is equal to 15 minus 36 and this is equal to minus 21. So it is decreasing in this interval. So this is decreasing here, and let's see from 1 to infinity and from 0 to negative 3. So from 0 to negative 3, let's pick a point, easy point, let's say negative 1. Negative 1, this becomes, this whole thing becomes negative 1, then this becomes 12 minus 24 because this is negative 1 equals to negative 12 and minus 36. So this is negative 48 and it is also decreasing in this interval. And let's see from negative 3 to infinity. Let's pick a value, let's say 10. Let's pick a value, let's say 10. So this becomes 12 times 100. This is equal to this plus 24 times 10 equals to 1440 minus 36 equals to 1404. So it is increasing here. So from it is going from increasing to decreasing. So this is an inflection point, and for another inflection point is it is going from decreasing to increasing. So 0 is not an inflection point because it is going from decreasing to decreasing, it remains decreasing. So let's see now 1 to infinity. So let's pick a value, let's say 2. So this becomes 12 times 2 squared is 48 plus 24 times 2 is 48, 96 minus 36, this is only 60. So this is positive here. So it is going from negative to positive. So 1 is also an inflection point and there are no other inflection points. So let's check our answer correct. Let f of x equals to negative 1/2 x squared minus 6x cubed minus 27x squared. For what values of x does the graph of f have a point of inflection? First let's find the second derivative. So f prime of x equals to, this becomes 4 times negative 1/2 equals to negative 2. So negative 2x cubed minus 18x squared minus 27 times 2 is equal to 54 minus 54x. Let's take another derivative. So f prime prime of x equals to minus 2x cubed times this, so this becomes minus 6x squared minus 36x minus 54. So let's see what we can take out of from this. So we can take out an 6 from both these, from these three. So this becomes, let's erase this, what we do not need, we do not need this. So we have to find when this is equal to 0, our critical numbers. So we can factor out in 6, so this becomes 6 times, we can factor out negative 6, so this becomes x squared plus 36 plus 6x, 6 times 6 is 36, minus 54 divided by 6 equals to, I think, 9. So 9 plus 9 is equal to 0. We can divide both sides by negative 6 to get rid of this. So plus equals to 6 and times equals to 9. So we can do only this by 3 times 3 and 3 plus 3. So this becomes x squared plus 3x plus 3x plus 9 equals to 0. So this becomes x times x plus 3 plus 3 times x plus 3. So this becomes x plus 3 squared. This whole thing becomes x plus 3 squared, this is x, not y, is equal to 0. So x has to be negative 3. So x has to be negative 3. This is our critical number, negative 3, and negative 3, x is equal to negative 3, x equals to negative 3. So let's see now in the number line. Our only critical point is at negative 3. So let's see in the intervals. Let's see in the interval from negative 3 to infinity, negative infinity. So let's pick a value, let's say negative 10. So this becomes negative 6 times negative 10 squared is 100. This is negative 600 minus 36x. 36 times negative 10 is positive. So plus 360. This we multiplied by negative 10. So this becomes plus 360 minus 54. This is negative 294. So it is decreasing over this interval, and let's see the last interval from negative 3 to 0. From negative 3 to 0, it is also this becomes 0. Let's pick a value, let's say 0. So this is 0, and we are left with negative 54. So negative 54, it is also decreasing, from it is going from negative to negative. So it has no points of inflection. Correct? Negative x to the 7th power plus 7x to the 6th. For what x values of x does the graph of f have a point of inflection? So let's find f prime. F prime of x equals to negative 7x 6th plus 7 times 6 is 42. 42x to the 5th. Let's find f prime prime of x. F prime prime of x equals to, so this becomes negative 42 x to the 5th plus 42 times 5. 42 times 5 is equal to 300, I think. 42 times 5, 210 plus 210. So this is our second derivative of f. So now we have to find when this is equal to 0. So this is, what was it? This becomes x to the fifth, then x to the fourth. Negative x 7x to the sixth plus 42 x to the fifth. So this becomes x to the fourth. So okay, so this has to be equal to 0. We can factor out and 42. So if we factor out and 42 x to the fourth, then this becomes negative x plus 5 times x 5, only 5. So this is equal to 0. So this is only possible when x is equal to 0 or x is equal to negative 5 only, when x is equal to 5. So these are our candidate inflection points. So let's make a number line. Let's write this here, x equal to 0, 5. So these are two values. Let's make a number line and let's see. So let's say this is 0 and this is 5. First we have to find between this interval. So it is from 0 to 5. Let's pick a value, let's say 1. So we have to put this into this value. So this becomes 1 times 1. So negative 42 plus 210. This is positive. This is positive here. And let's see from 5 to infinity. So let's pick a value, let's say 10. 10 is very high value for this problem. So negative 42 times 10 to the fifth, 10 to the power of fifth, 10 to the fifth power. This is equal to negative, very high, plus 210 times 10 to the fourth. It's still negative, so our first inflection point is at 5 because it's going from positive to negative. And let's see in this interval from 0 to negative infinity. Let's pick a value, let's say negative 1. Let's say negative 1. So this becomes negative 42 times negative 1 to the fifth is negative 1. So negative 42 times negative 1 is 42 itself. 42 times plus 210. So this is 252. It's still positive, so our only inflection point is at 5. Let's check our answer, and we got it right. So let this f of x equals to 1/2 x fourth minus 4x cubed. For what values of x does the graph of f have in point of inflection? So first let's find the f prime of x. F prime of x equals to, this becomes 2x cubed minus 12x squared, and let's find the double prime of x of f. F prime of x equals to the derivative of this. So this becomes 6x squared minus 24x. So when this is equal to 0, we can factor out and 6x. So this becomes 6x times, this becomes x minus 4. This is equal to 0. So this is only possible when x is equal to 0 or 4. X equals to 0 or 4. So let's make a number line. Let's say this is equal to 0. This is 4. First let's find between this interval from 0 to 4. Let's pick a value, let's say 1. So this becomes 6 minus 24. 6 minus 24 is negative, so it's decreasing. And let's see, from 4 to infinity it becomes, let's pick a value, let's say 10. So this becomes 10 to squared is 600. 600 minus 240 is greater than 0. So we are increasing over this interval. So our inflection point is at 4 because we are going from negative to positive also. 4 is our inflection point. Let's see, from negative infinity to 0. So let's pick a value, let's say negative 1. Negative 1, so this becomes 1. 6 times negative 1 squared is 6, minus 24 times negative 1 is plus 24. So this here we are increasing. So 0 is our also a point of inflection of f. So and there are none other, so let's check, and we got it right.